This is a video walkthrough for the Unit 2 review. In 1 through 6, we're asked to write the equation of the line for each shown or described, and then convert it to standard form. That means we are not going to start in standard form, but we're going to convert whatever we write into standard form. In number 1, we can see a graph, and in that graph, I'm observing that we have a y-intercept, which we call b, that is equal to positive 2. Also, we can find the slope from this graph. If I go from one point to the next point, I am going down 1 and right 3. That gives us a slope of m equal to negative 1/3. That means that in y equals mx plus b form, which we call slope-intercept form, the equation can be written as y equals negative 1/3 times x plus 2. Now we're going to convert that equation into standard form. In standard form, there are no fractional coefficients, so we'll need to multiply all terms by 3. Remember to distribute that multiplication to all of the terms or all of the addition in both sides of this equation. So we wind up with negative 3y is equal to negative x plus 6. Now I'm going to add x to both sides, and I'm going to write the x term first so that we get it in ax plus by is equal to c form. And that's the equation in standard form. The equation's coefficient of x, a, is equal to positive 1. That's okay. We need a positive coefficient for a. All of the rest of the coefficients can be integers of any sign. In number 2, we have an equation whose slope is given. The slope is m, and the y-intercept is given. Remember that the y-intercept always has an x value of 0. So we can write the equation in y equals mx plus b form. Y is equal to 3/7 times x minus 2. Now we can multiply both sides by 7, or all terms by 7, in order to clear any fractional coefficients, because standard form does not allow for fractional coefficients. And rewriting 7 times y is equal to 3 times x minus 14. Now I'm going to subtract 3x from both sides, writing the x term first, because the standard form is ax plus by is equal to c. There's only one thing left to do, and that is to ensure that the coefficient of x, which is a, is a positive number. In order to do that, we can multiply both sides or all terms through by negative 1, and that will give us the equation in standard form. Now let's check out number 3. We have the slope again, that's our value for m, and we have a point. However, that point is not the y-intercept, it's just an ordinary point, x1, y1, nothing special about it. It's not the y-intercept because the x-coordinate is not 0. So we can write this in point-slope form, which is y minus y1 equals m times x minus x1. The y1 value is the y value of the point, m is the slope, and the x1 value is the x value of the point. X minus negative 4 is the same as x plus 4. Now we can distribute, since we don't have any fractional coefficients to worry about, distribute the multiplication over the addition on the right. And now I'm going to add 3x to both sides, and I'm also going to add 1 to both sides. And now we have the equation in standard form. The a coefficient, or the coefficient of x, is positive 3, so that's allowable. The other coefficients can be integers of any sign. For number 4, we are writing the equation of a line that passes through 4, negative 3 and negative 2, negative 1. We have 2 points this time, but we don't have the slope. Luckily, we can compute the slope. The slope is the change in y divided by the change in x, and on the top of the fraction we'll subtract the y coordinates. Remember that the y coordinates are the second numbers in each ordered pair. And then on the bottom we're going to subtract the x coordinates, and we need to subtract them in that same order. In other words, whatever y coordinate we started with on top, we'll use the x coordinate from the same point on bottom to start with. -3 minus -1 is -3 plus 1, -2. 4 minus -2 is 4 plus 2, which is 6, and that slope reduces to 1/3. Next, we can write this in point slope form and choose either of the 2 points. It doesn't matter which one to start with. So I'll use the first point. Y minus the y coordinate would be y plus 3 is equal to -1/3, which is our slope, times x minus the x coordinate of that point. Since we have a fractional coefficient this time, I'm going to multiply both sides of the equation by 3. So 3 times y plus 3 is equal to 3 times -1/3 times x minus 4. On the left side, we can distribute the multiplication over the addition in the parentheses. And on the right side, we're going to want to multiply those numbers together first before we distribute that multiplication to the subtraction in the parentheses. Multiplying, we get a result of -1, and -1 distributed as a multiplication to each of the terms on the right gives us -x plus 4. Now I'm going to add x to both sides and subtract 12 from both sides, and that gives us a final result of x plus 3y is equal to -8. For number 5, we have a line that passes through a point and is parallel to x minus 3y is equal to 6. So we need to know the slope. The slope of the line that's given here can be found by solving the equation for y. So I'm going to subtract x from both sides and then divide all terms by -3. So in slope-intercept form, this equation gives us y is equal to 1/3 x minus 2. That means the slope of that line is 1/3. So therefore the slope of a parallel line is the same slope. Now we have the slope that we need and the point for the point which the line passes through. That can be written in point slope form. So y minus the y value of the point equals the slope times x minus the x value of the point. I have a fractional coefficient, so I'm going to multiply both sides by 3. 3 times y minus 2 is equal to 3 times 1/3 times x minus 3. On the left side, we can distribute that multiplication to both terms in the parentheses, and then on the right side, we're going to want to perform that multiplication 3 times 1/3 first, and that just leaves us with a 1 to multiply times x minus 3. Now we can move the x term to the left side of the equation, which will give us -x plus 3y, and that -6 needs to move from the left side of the equation to the right, so we can add 6 to both sides. -3 plus 6 is 3. And we're almost in standard form, but the coefficient of x is -1, so we need to multiply all terms through by -1 in order to have a positive coefficient for the x term. Now let's take a look at number 6. This time we have the equation of a line that passes through -4, 1 and is perpendicular to the given line. Again, we need to find the slope of that given line. I'm going to do so by subtracting x from both sides so that we can write it in y equals mx plus b form, and next dividing by 2, and that gives us y is equal to -1/2 times x plus 4. The slope of that line is 1/2. The slope of a perpendicular line is the opposite reciprocal, which would be +2. And now we can write the equation in point slope form. Y minus the y coordinate of the point equals the slope times x minus the x-coordinate of the point, and x minus -4 is the same as x plus 4. Now we can distribute the multiplication on the right, no fractional coefficients to worry about, and subtract 2x from both sides, and add 1 to both sides. And lastly, the coefficient of x needs to be a positive number in order to have this in standard form, so we'll multiply all terms through by -1, and now our equation is in standard form.